quiz on it yesterday before we jump into 5.7, 5.8. So there's two more sections. What these two sections get into, we're going to use again some of the stuff you just quizzed on, but certainly adding some layers to this. They're the properties of parallelograms. So you certainly jumped into parallelograms a little bit last year. So some of this should be familiar. Some of it is definitely going to be new. But if you remember kind of what a parallelogram is, they have a bunch of properties to them. There are 5 that we're going to talk about. We're going to write down the first 2, and then we'll kind of sketch in what a parallelogram should look like based upon those first couple of properties. So the first couple of properties of a parallelogram is that opposite sides, and this is the big one, are parallel. Hence the name parallelogram. Okay? So that's pretty obvious. Opposite sides need to be parallel. The other thing that is true that's pretty obvious that you should all know and remember from last year is that opposite sides are also congruent. What I would now like you to do off to the right, because then it'll make 3, 4, and 5 a little bit easier and just refresh our memory a little bit on what a parallelogram looks like. We want opposite sides that are parallel, opposite sides that are congruent. So the basic parallelogram, typically you're going to see it look like this. So this is kind of what a parallelogram looks like. It looks like a rectangle that's sort of slanted, leaning over. And what we are saying then is opposite sides are parallel. So I would put a single arrow here, saying that those 2 sides are parallel. And then we would put some double angle symbols here, or double arrows that would say that those 2 sides are parallel. So that's property number 1. Opposite sides are also congruent. So this side and this side will put single ticks indicating that those are congruent. And then this side is congruent to that side. Those things you would have talked about in the past. Last year you did parallelograms, you had a little flow chart and all that good stuff. You definitely would have talked about those couple of ideas. Eventually, what we get into tomorrow, if I drew this in, you don't necessarily need to draw this in. Not that you can't. What would everybody call this thing right now? What is that most commonly known as? A rectangle. But in a rectangle, aren't the opposite sides parallel? And aren't the opposite sides congruent? So that's why you had that little flow chart last year, because this is still a parallelogram. It's more specific. It has its own unique properties, but it is still very much a parallelogram. If we look at that, now if all the sides are the same, isn't that a square? But doesn't it still satisfy both of these 2 initial conditions for a parallelogram? So a square is also considered a parallelogram. Okay? It's just a little more specific. All right, now using that graph, I kind of wanted you to have this graph. So the next few aren't quite as obvious, not that they're hard, but I wanted a little diagram to kind of show you what's going to be happening. These 2 are obvious. The next 3 will largely be new. What we want to know about these now is opposite angles are congruent to each other. So write that down. I'll kind of shade in and explain what that's referring to. If this is one of our angles right here, the opposite angle, the angle opposite of it is this angle over here. So if this is 40 degrees, this is also 40 degrees. These will have the same degree measure, as will then these 2 angles here. This angle is opposite of this angle. These guys will have congruent degree measures. Okay. The next one, if I said consecutive angles, so write that first. Consecutive angles are, and then we'll talk about what that means. If you understand kind of the word consecutive means kind of right next to it, the very next one. So angle 1, if I ask you what angle is consecutive to angle 1, isn't angle 2 right next to angle 1? Isn't angle 4 also the very next angle, depending on which way we're going, clockwise or counterclockwise? Angle 2 is consecutive to 3 as well. 3 is consecutive to 4. It's just the angles right next to it. All right. Our theorem then is, if we kind of look at consecutive angles are supplementary. You don't necessarily need to mark yours up. because it may not make sense when you look back. So we're going to draw something else in here. But what that simply means, these two guys together, let's say this looks like maybe a 70-degree angle. If this is a 70-degree angle, what is this angle over here going to be? Yeah, that's got to be 70 because those are opposite angles. That's this property. If I ask you what this angle then is going to be, that's going to have to be what? 110, because these are supplementary. The angles directly next to each other should always add up to be 180. This then is also 110, and we've satisfied opposite angles are congruent. And then consecutive angles always add up to be 180 degrees. So that's what these two properties are saying. All right. And then last but not least, the fifth one that we want you to know and be able to use deals with another old idea that you haven't talked about since last year, and that is the idea of diagonals. So let's review what a diagonal is, and we'll talk about the property. I'm going to draw in, I like using a hexagon. So let's say I drew in a hexagon. Last year when you would have talked about diagonals, you actually would have done problems. How many diagonals does any sort of a shape have? Diagonals are when you go to any vertex. So I'm going to go to this vertex here, and then I'm going to connect this vertex to any vertex that's opposite of it. So not next to it. So I would get a diagonal to this angle. I would get a diagonal to this angle. I would get a diagonal to that angle. So that vertex has 3 diagonals. Well, I could also come over here. I would get a diagonal here, here, and here. So then I get 3 more, and then I have 6. All right. You remember doing it? Then you had to kind of find out how many there are overall. Okay, that was something you would have done as kind of the geometry idea last year. We're not going to dive into it that much. I just want you to review kind of what diagonals are. So if we go to our parallelogram, if I go to this angle right here, and I try to draw in a diagonal, here we had 3. If I draw in a diagonal from this vertex, how many diagonals will I be able to draw in? Yeah, just 1. I can only go to this angle. These are consecutive, so I wouldn't connect them. I only get 1 diagonal. If I go to the other vertex, I would also only be able to draw in 1 diagonal. I could go to this vertex, but this is a duplicate. If I go to this vertex and draw it in, we've already got that one drawn in. So those are our diagonals. And the property we want to know, diagonals, remember the word bisect from the first half of this module? They bisect each other. So what that basically means is the point where they intersect, this is the midpoint for both of these segments there, both of those diagonals. So if this segment right here has 11 as its length, then this segment here would have 11 as its length. If this one is 6, then this one is 6. That's what we're talking about if they're bisecting each other, okay? Those are our properties. All you're going to do in these next 7 or 8 problems is actually familiarize yourselves with these with actual letters, with an actual graph, so on and so forth. So if we come down here, it says, given HJKL is your parallelogram, answer the following question. So the first one is dealing with the idea that if you look at side JK, so here is JK, here is our parallel symbol. Which side is JK going to be parallel to? HL. All right, this is what it's parallel to. So you're going to write that in. So you're going to put HL. You do need to put the line segment symbol above it, but those are our parallel sides. That's what JK is parallel to. All right, the next one, find LK. LK is the bottom of our parallelogram. And number 2 is asking you to identify the segment that it must be congruent to. And it has to be congruent to its opposite side. So HJ would be what is congruent to KL. All right, and then we use the proper notation for that. So numbers 1 and 2 correspond directly with numbers 1 and 2 that we wrote above. They're also the most obvious. All right, those should be kind of just obvious by looking at a parallelogram. But those are the first 2 properties that we mentioned. The angles now, just be careful. Again, last module we labeled these, understand how we could find them. If I did LHJ, angle LHJ, I'm going to go from L, I'm going to go to H, and then I'm going to go over to J. So the angle created from L to H to J is this full big angle in the upper left-hand corner of this parallelogram. All right, notice it does get cut a little bit by a diagonal, but right now we want that whole angle. And then I want you to tell me, so try this real quick, what angle is this big blue angle up here going to be congruent to? And then write that in, see if we understand that. How's your wrist doing, Maria?
Okay.
Surviving? Okay. Did you know Maria got hurt?
Did not.
Yeah.
That's hard.
She got in a fight.
Yeah, the fight. What's the other person look like?
Exactly. Broken nose.
Wow, she looks like Riley.
Oh,
Really?
that's bad.
What?
You really messed her up.
That's why I took.
So what happened? You tripped and fell?
No, she got attacked by Rick. Yeah.
Attacked by a raccoon? Did you have to get a rabies shot?
Yeah.
Did it hurt?
No.
Not for Maria.
How
Yes.
tough is it in class?
Yeah.
No, maybe
That's
not
right.
tough. I think Sage is the toughest.
Really?
Sage
I don't know about
is
that. She's just laughing.
Yeah, I don't know about that one. All right, anybody confident in this angle? What angle would that big blue angle be congruent to? And then name it correctly. Yeah, Hannah. Say that one more time. Good. So she went JKL. It's got to be the opposite angle. So the opposite of this big angle is this big angle in the bottom right-hand corner. And she named it JKL. So angle JKL. Now, remember, this could have been named a little bit differently. Hannah went in this direction to name this angle. We also could have gone LKJ. So if you did that, that is also exactly correct. As long as the K, that vertex in the middle, you can name that angle either way. Okay, so kind of remember that. We haven't had to name an angle in a while. Okay, LKH now. Again, make sure we understand what angle that is giving us. So L to K to H. So here is L, here is K, here is H. So we are looking for this angle right here. And then I want to know what angle that is congruent to. Actually, try that one because this one is not necessarily one of these 5 properties up here. It's an old idea. But when we see it within parallelograms, it starts to become a little bit harder for people to see sometimes. So tell me what angle this has to be congruent to. From L to K to H, what angle would this be congruent to? Okay, anybody think they know that one? Not quite as obvious. What do you got, Hannah? This is J. Okay, so she said J to H to M. So that would be this angle right here. All right, so she is correct. So we're going to name that JHM. Do you know why that's correct, Hannah? How would you explain that? Okay, so eyeballing it a little bit. So an educated guess. Okay. There's a nice way so we don't have to worry about assuming it. We just quizzed on it yesterday. Aren't these sides parallel to each other for sure since it's a parallelogram? And then didn't we do a whole bunch of problems for the last week and a half where we had another line that intersects those two that we would call a transversal? So now, Hannah, what kind of angles are these? Do you know? Good. And alternate interior angles are congruent. So if this is the angle I gave you, its alternate interior angle is this one. And that's how we would know for a fact that those are congruent versus just kind of eyeballing it and assuming they are. Okay. Okay, 5. MK. So find M to K and find out what segment would be congruent to MK. So here is MK, just this segment right here. The segment that needs to be congruent to is what, Maria? Good, HM. All right, so that right here is congruent. This is the whole, these two diagonals, when they intersect, the reason I actually use an M right here is to kind of identify this the idea of a midpoint. So these two segments are congruent, as are the two that you're being asked about in number 5. All right, those are also congruent. All right, JKL or KJL. So here is, where is it? KJL is this angle. I want to know what angle that is congruent to. Keep in mind what we just talked about a minute ago when Hannah did it. We have two parallel lines here. And then we have a line that is intersecting both of those. So can we use kind of that same logic? All right, Sarah, what do you got? Good. H, L, J. So she gave me this angle right here because these are alternate interior angles. So H to L to J. All right, those are our congruent angles. All right, last one, number 7. Do number 7. This definitely is one of the properties above. So if you're not sure, it's probably the trickiest of them, somewhat tricky. It is definitely a property above. So it's got to deal with the idea of angles. So only focus in on, there's only 2 of them up there that talk about angles. And see what we think. All right, what do we got? Anybody confident here? Jackson, what do you got?
98.
Good. That should be 98 degrees. Why is that, Jackson?
Because you can tell that the other one is bigger than 90 degrees. You just subtract 82.
Because if we go up here, Jackson, which one are we talking about?
I have no idea.
Okay, in some ways, it's not a bad thought process. Everything we do so far has largely been congruent or supplementary, right? Certain angles. So when he looks at these, he's understanding there's no way these are congruent to each other because this is an acute angle. This is bigger than 90 degrees. There's no way those are congruent. Right. If we look at number 4, those are what we would call consecutive angles. They're right next to each other within the parallelogram, and consecutive angles are supplementary. So what he understood then is these two guys together had to be 180 total. So the whole idea of taking the 180 minus 82 is correct, and what you were left with is 98 degrees. That's what this yellow angle here would need to be. All right. So 98 is correct, and it's because of the whole idea of consecutive angles being supplementary. Okay. So 1 through 7 is just, here's a graph now. Let's apply those properties. When we now do the rest of these, now it's going to kind of throw some algebra in here. Same thing that we've been doing, set up an equation to solve this. So when you look at number 8, notice how you have y's and x's. So we're going to want to solve for both. This is about as easy as it can get. Notice how we have y's right here. We have y's right there. Aren't those opposite sides? And in a parallelogram, the opposite sides are congruent. So our equation is just setting those equal to each other. And then we are all very competent at solving these. You just go through, solve for y. Once you have that equation, and we should ultimately end up with a y value of 10. We still have the x's though. If we look at how those are related to each other and in the context of all of these properties, aren't these also opposite sides? and opposite sides have to be congruent. So the same exact thought process, the 7x minus 4 has to get set equal to the 4x plus 5. And then that's our equation that we would go through, solve for x. All right. So I'll subtract the 4 over the 4x, add the 4 over the other side. And then our x is 3. All right. All right. Number 9. These are your angles. So this is referencing this bottom left-hand corner angle is the 8x minus a 4. And then the 3x plus 6 is giving you this angle up here. So don't think these are the sides. Those are those angles. So Jackson kind of just talked about it a little bit. When we look up here, there's only a couple that deal with angles. We want to identify, are those opposite angles or are those consecutive angles? Because opposite angles are congruent, consecutive angles are supplementary. So when we look at that one, are these consecutive or are these opposite? Opposite. These are across from each other. They're not right next to each other. And our property tells us that opposite angles are congruent to each other. So just like those previous two, those guys have to be set equal. And then again, just a simple little algebra equation that we need to work our way through and solve. All right. All right, so go through that. Confident we would all get that part right. And in this case, we should get an x value of 2. Then 9 and 10, I give you for a reason, back to back, just so we can kind of make sure we understand the vocabulary here. And number 9, these angles are across from each other. All right, so that's why they're congruent. Opposite angles are congruent. When we look at number 10, if you look at the two angles that now you're given with, these two angles are not across from each other. Like the angle across from this one would be u. So these are not opposite angles. These are now what we are referring to, because again, this is somewhat of a new phrase here, consecutive angles. They're right next to each other. They're consecutive. Consecutive angles, then, we said, are supplementary. So you're adding those now, and we know supplementary means when we add them, they have to add up to be 180 degrees. So opposite supplementary angles keep those things straight. All right, combining like terms. Subtract that 15 over. Oh yeah, we got a decimal in this one. We realized last period. That's okay. It doesn't mean you're wrong. Decimals are okay. Divide by 10 here, and you should get 16.5. All right. So again, it's similar to what we just quizzed on, just new properties. Once we know our properties, that's how we're going to set up our equations. And most of the time, they're either congruent or supplementary. All right, number 11. The y's are pretty straightforward. So if you look at the y's and how they relate to each other, aren't the y's labeling opposite sides? All right, and we know opposite sides are congruent. So that one is pretty straightforward. Those have to be congruent to each other. Once you have your equation, just again, work your way through solving that. Add your 2. And then we should get y to equal a 5. The x's cause a little more confusion than I anticipated last period. So understand what these are labeling. These are giving you this segment right here. Those are not the angles. And then the 10x plus 5 is giving you this segment right there. All right. So what this property, or what this is testing you on, the property this is testing you on is this one right here. That diagonals, when they intersect, bisect each other. That means it cuts each other in half. So when we look at this here, this point, if both of these are getting bisected, this is again a midpoint for both of those diagonals. And if that is a midpoint, that means if this has a length of 20, doesn't this guy also have a length of 20? All right. So those also are congruent. So this 6x plus 9 has to be equivalent to the 10x plus 5. So it looks similar to the previous ones, where you're just going to set those equal to each other. And then we're working our way through solving that. All right, so we want 4x equals a 4. So as you do that, you should get that for your x. Okay, number 12. 12 and 13 make you think a little bit. This now you're going to have to apply a lot of different little ideas here. So I'm going to give you a couple minutes. See what you can do with 12. See who can think a little bit, who can be systematic. Again, you need to know one to figure out the other, and then you need to know that other to figure out the next one. See what you can do with number 12. Yeah, sometimes we just have to. Let's put that in here.
Good morning. Please pardon this interruption for one brief announcement. Due to the return to yellow mitigation, all students will be eating in the commons, grill, and mezzanine. Freshmen, sophomores will no longer be in the East Gym. All students will be eating in the commons, grill, and mezzanine. Thank you.
Okay, real quick. Everyone that I saw had this set up, so that's good. We understood that these are opposite angles. Opposite angles are congruent to each other. So everyone that I looked at had gotten that far. We knew we could set those equal. And then as we were working our way through that, pretty much everybody got the x right to be a 14. Okay, so opposite angles, congruent. That's why we set them equal. We still needed to figure out our y and our z, though. All right, what would we do next? And we got the next. Haley, what'd you do next? Good. So she said she found the 2x plus 15. So what she means by that is she took this 14 and she plugged it in for this x right here. So 2 times 14 would have given her 28 plus 15. What does that mean this angle is overall, Haley? Good. So this is a 43-degree angle. Now, there's nothing to do in the problem that asks you for that, but you need to know that before we can move along here. All right. Once she knew that, what'd you then do, Haley? Good. She understood then that these are consecutive angles. This yellow angle and now this 43 angle, those are consecutive. And she knew the property was that those have to add up to be 180. So she added these two angles together, set them equal to a 180. That'll give you Y. I'll let you solve that. You can solve that. Z, though, we can figure out right away, right? Because of the exact same idea. Aren't these two angles also supposed to be supplementary, these guys? So these two angles together have to be 180 degrees. We know this is 43. So doesn't Z have to be 180 minus 43? So this needed to be 137. Don't worry about the obtuse and acute nature of those as we look at those. Just pretend that's right. All right, so this is 137. This was, and then our Y and our X's both ended up being 14s. Okay? Okay, can you pass it out? Okay, bring this tomorrow. I wouldn't mind if we have some time tomorrow to do this bottom one, just kind of put it all together, see if we can kind of break it all down. But you do get some homework tonight, so that's what Mr. Kuba is going to hand out. And then we'll see how that goes tonight.